So my name is Dave McCrory, and I work for VMware with the Cloud Foundry group. And I'm going to kind of start from a very, very high level of what Cloud Foundry is and go all the way deep down into how it actually works. And then at the end, I'll take some QA. I'm betting you guys will have some questions. So if you haven't heard of what Cloud Foundry is or anything else, just bear with me through the first set of slides, and all of that will be explained. If you do, you'll find out a whole lot more, I'm sure, than you've known before. So usually when you start doing coding, you start off with an idea, and you write some code, at least if you decide you actually want to follow through with that idea. And then you end up refining that idea, and at some point you end up with a suitable version of your code that you end up producing into a product or an app, we'll call it. And your app you then want to do something with. Usually you want to deploy that app. So deploying apps the old way usually involved quite a lot of complicated steps. At least if you had a bigger app, you would end up having to configure app server, a database. You'd have to deal with some level of complexity, and as you wanted to do more and more with that app, the level of complexity in configuring it and doing other things went up as well. And so deploying apps the new way would be if you only had to type a few commands, and with Cloud Foundry that's the case. So if you look up at the example, those are actually the real commands you would type out to deploy a multi-tier app. And this would be more of a traditional 3-tier style web app that you would deploy. So you could have a more complex, so to speak, application that was, say, multi-tier, but you wanted it to horizontally scale. You wanted it to be able to handle a far larger load. So your application's grown, you want to simply scale it out. Traditionally, what you would have to do is go back and figure out how to reconfigure all of those things that you needed to configure before, whether it be load balancers or routers or application servers or database or name another layer inside of an infrastructure, and you would have to deal with it. So here's a scaled multi-node distributed app, and if you look, something you'll see we've got some different interesting components here. RabbitMQ is simply a messaging solution. We've got Redis. I'm sure most of you have heard of Redis. It's just a in-memory key value store. We have MySQL and we have MongoDB in this example, and there's a load balancer above them, and there's a front end and back end. And so this would probably represent weeks and weeks of configuration, and even if you were using scripted deployment tools and things, it would be just super complicated. So doing something like this with Cloud Foundry is actually only a few commands, and they're pretty easy to remember. These are actually the commands that we use to deploy that app that I just showed you the example of. And you can see I've highlighted a front end and back end, and basically we're just pushing our front end code. Then we're setting the instances to 8, so we want 8 simultaneous copies of that running. And then the next line you can see we're setting up a back end with 2 instances. Then we're creating the services, so, and I'll explain, like I said, all of this shortly, but basically, we're creating a MySQL service. You can see it's literally one command to create that. We're creating a Rabbit instance, Redis beneath that, and then Mongo. And you'll see at the end of each of those, we've given it a name and we've bound it to FE, which is what we're calling our front end app. And then at the bottom, you see the Mongo is bound to the back end. And then you'll see we have two more bind commands. One is binding the back end as well, so we're binding both the front end and the back end to Redis. And you'll see the next line, we have Rabbit that we're binding to the back end. So both Redis and Rabbit are both bound to both the front and back end. And then we update our code, and when you actually do the update, it would kickstart your app with any of the changes, and you now have an app that you've deployed in just a few lines of code that literally is 8 instances on the top end and 2 instances on the back end. So you can deal with very complicated configurations or very simplistic configurations, and they can be kind of a monolithic 3-tier app, or they can be horizontally scaled, kind of a newer application. So what really is Cloud Foundry, and why am I telling you all this? And what makes Cloud Foundry different, I guess, are probably all questions you might have. So cloudfoundry.com is a hosted service. You can literally go online right now, sign up, and you can literally start pushing applications. And applications can be Java apps or Spring, Ruby, Rails, Sinatra. You can do Node.js. You can deploy all of these in the same account, all at the same time, all on an instance. Right now, while we're in beta, you can actually do, you can consume up to 2 gigs of memory, and that's really the primary constraint of the system. So you get lots of CPU, and by the way, Redis and all of those other things do not count against those 2 gigs of memory, and you get a pretty good amount of storage as well. All at no cost. It's very easy to use. So that's the .com site. The .com site's actually a live running version of what we have in .org, which is Cloud Foundry is actually an open source project as well under Apache 2. So all of the Cloud Foundry code that runs Cloud Foundry is written in Ruby. The exception to that is Event Machine. We do leverage Event Machine, which isn't written in Ruby, but obviously the bindings are very friendly. Outside of that, it is all Ruby code. So the cool thing you can do is you can grab the code from the repo and deploy your own instances of Cloud Foundry behind your firewall. We're actually going to be coming out soon with what we call the microcloud. And that's where all of Cloud Foundry is actually instantiated inside of a virtual machine. So you fire up the virtual machine, you point the client to it, push your code or provision your services. They all come online in that virtual machine, and you just deploy your app. So literally in a matter of minutes, you can start deploying apps that are fairly complicated configurations. So it makes life very, very easy, and it gives you a lot more flexibility than even previously when previous PaaSes existed. You couldn't get at any of these other things. You certainly couldn't run one on your laptop or something like that. So it brings a lot to the table. So now starting to go kind of the next layer deeper, I'm going to talk about the developer visible architecture. So these are things you can use just writing to Cloud Foundry. So they're application concepts. These are around what the different constructs that are in Cloud Foundry that you leverage. So there are applications, so that's your code, your libraries, all of the things that you need for your app to be your app. Instances are the actual instantiations of that code. So when I showed you the instances being 8, that means 8 copies of my logic were scaled out for the front end, for example. So each of those is an instance. You can control how many instances. The instances can be dynamically scaled on the fly while your app's running. You can scale them out and scale them back in as you want, literally from the command line. And it's really fast. This isn't like provisioning a VM on EC2 or something like that, where it takes a fair amount of time to spin them up in some cases, depending. These are not instantaneous, but you would measure it in seconds, not minutes or even longer in some cases. Apps are mapped via URLs, so you can actually map and move around on the fly while the system's live, mappings of URLs. So you can actually swap old code out while your app continues to run. So this is pretty powerful as well, because now you actually have the ability to hot migrate your site over. Try out your new code on one instance while you have 3 instances that are the old code, and if everything looks safe, you can move over your other instances. That's not without flaw. You have to do some management, or you have to deal with session state issues depending on how you designed your app, but you can do it. And we actually do a lot around that today with our actual site, the cloudfoundry.com site, which lives on Cloud Foundry. And we're able to swap out and version the site many, many times without having downtime of the site. In addition to that, we have services. And so the idea behind services, that would be currently MongoDB as a service. We have MySQL, we have Redis, and we have RabbitMQ. We're going to be adding some more services in the very near future. And one of the design philosophies is to externalize as much of your state information as possible, so not persisting things locally in your app logic. That's actually what you should do in any of the kind of cloud-esque solutions. You want to externalize the state. Trying to store things in files and other things locally as part of your logic to deal with sessions or other things ends up being bad in that it stops you from being able to dynamically scale in and out. It also makes it more difficult to deal with failures. So we're not preventing you from doing any of those things, but if you want to follow scalable design patterns that can withstand failures, that's one of them. So a logical view of Cloud Foundry from the absolute highest level is there's an infrastructure abstraction. Cloud Foundry doesn't care about the infrastructure beneath it. So it truly does not care. It could be a VM, it could be physical hardware. You can deploy Cloud Foundry. There's some scripts out there to deploy it on your MacBook. And it just runs natively on Mac OS X. So it truly does not care about the infrastructure, so you don't have to worry about the infrastructure either. And then Cloud Foundry itself is an abstraction in that it's abstracting out all of the different instances. It's providing all of the messiness, so to speak, it's taking care of for you. And so in this diagram, the infrastructure could be thought of as infrastructure as a service for cloud. Cloud Foundry would be the platform as a service, and the user, your apps, or if you ran your own instance and provided it to others, then your users' apps would be software as a service. So going another layer deeper into what this is and actually how it works is going to what's under the hood, so what really happens when you're pushing that code up. And depending on interest, I can actually, a little bit later, I can give you guys a demo kind of on the fly of what it's like. It's actually very trivial to push code onto Cloud Foundry. I don't know, is anybody interested in seeing that, or should I just move on further down the list? Anybody? No? No interest? Okay. All right, so from a logical view, this is how a flow with Cloud Foundry work. You have at the top, you see VMC client. That's actually written in Ruby as well. It's part of the open source. It's the client. It communicates via JSON. It passes JSON messages back and forth. You authenticate and pass through a series of load balancers and routers and hit the cloud controller, which is the API endpoint. It's what's generating that JSON, allowing the flow. People accessing the apps using a browser or something else, it's consuming whatever your app's emitting, will also pass through load balancers and routers. We have the DEAs that are actually providing the home for the resources that your app is using. and the services that actually the DEAs also interface with, and then the health manager, which is looking at all of that and allowing or trying to make sure that a consistent state is maintained. So kind of diving a little bit deeper into how that works, we have a series of components that, and I'll go through. This is really all of the different things that are happening inside of Cloud Foundry. There are load balancers, routers, a pool of DEAs. There's NATS, which is a message bus that was written. It is, and I'll go into a little bit more about what NATS is. There's the health manager, which listens on NATS, the cloud controllers, and then services. So NATS is connected effectively to everything. So the health manager and NATS, the health manager listens to virtually everything that happens across Cloud Foundry's internal communications. And I'll kind of go through each of the different components. So the load balancer acts as a general purpose load balancer strictly for balancing load. It's based on Nginx today, very high performance. If you're not familiar with Nginx, it doesn't suffer from the C10K problem, and effectively that's because it works on an event loop. It's not something like Apache or something like that where it's dealing with trying to spin out or spawn threads for each session. It's incredibly performant and flexible. It's also not hardware. A lot of people think that you have to have hardware-based load balancers. You don't. In fact, most clouds out there layer load balancers, and at some point the load balancers that are closest to the code are software, not hardware. Then you have the routers. They receive all traffic that's coming through the system. There are many of them. Each of the layers in Cloud Foundry is horizontally scalable by design, so all the different layers scale horizontally. Routers also deal with mapping of your URLs to the actual application instances. The routers are dealing with, if your app is, foo.cloudfoundry.com, for example, it's mapping that to the actual IPs and ports that exist against the DEAs that are spinning up these instances. So you have user applications that exist on the DEAs, and the DEAs can be run in several modes. On cloudfoundry.com, we run it in a mode called multi-tenant mode. Multi-tenant mode means that we're actually doing process isolation, file ACLs, et cetera, and isolating the apps in that fashion. There's another mode that you can run DEAs in, which is single tenant mode. And the idea is that a single account is executed against a single DEA. That's kind of the Coke-Pepsi problem, right? Coke and Pepsi could never be on the same system. They would want contractual assurances that that was the case, et cetera. So single tenant mode gives the ability to change the isolation model from being process-based to being machine-based. That machine could be a virtual machine, or that machine could be a physical machine if you so chose to run a DEA agent on a physical machine. So again, you get the flexibility in Cloud Foundry. The way we run it on .com is multi-tenant mode, because it would be too costly to run it in single-tenant mode. But if you were deploying this, say, behind a firewall or something like that, you'd have the option to run in single-tenant mode. We also have the cloud controller. It's kind of the overall brain. The cloud controller deals with all state changes in the system, but it also deals with them in a way where it simply sends out the commands and expects them to be executed. So it assumes that everything is going well, and it assumes that everything has been carried out, and that's by design that it does that. All of its communications as well are happening across NATS when it's talking to the backend systems outside of that API endpoint that I described earlier. And then there are the services. So this is, again, what I was talking about, where it's MySQL, Redis, et cetera. So these service endpoints, this is how services are provisioned. So each time you do a request where we add, say, for example, the VMC create service command that you saw earlier, that actually spins out a separate, say, unique instance of MySQL. So you're getting your own MySQL process, your own database. It's a fully instantiated database. It's not simply an instance on a shared database. So then the health manager. What the health manager effectively does is it maintains consistency of the system. It goes back. I said earlier that the cloud controller assumes that everything has happened correctly. The health manager is what goes behind and actually makes sure that everything has happened correctly. So it it keeps a record of all of the messages that have been sent out across the NATS bus. So it knows what's really happened, if things have been successful, if they've failed, what's actually running, how it's deployed, and it trues that up on a 5-minute basis with the cloud controller, and that's how you end up with a consistent state. So it operates independently, and it makes sure that the cloud controller ends up being able to maintain itself as being the actual source of record. NATS is a message bus. It is written differently. People have asked, VMware acquired Rabbit, which is their message queue. People have asked why we didn't use Rabbit inside of Cloud Foundry, and that's because we actually wanted something as lightweight as possible, written in Ruby, that would fail as quickly as possible. So one of the philosophies is we want to know about a failure as fast as possible. We don't want retries. We don't want all of these things. We want something to fail because philosophically we're going to redeploy it as fast as possible and assume failure, and then have the entire system shift around that assumption. And so that happens so that we can find out about that faster. So digging down a bit deeper, how does all this really look? This is the eye chart. I realize it's not perfectly crystal clear, but this is kind of a diagram of how everything works. So when you push code up, what really happens, let's say you have a simple Sinatra app. You push that code up. Before you actually push the code up, on the client side, the VMC client takes and tears apart all of your files. It looks at each file, it creates a SHA-1 hash, it builds a manifest out of that, and it sends that manifest up first to the cloud controller. The cloud controller takes the manifest, looks at the SHA-1 hashes, and determines what it has seen before and what it hasn't. And then it sends the diff back down to VMC and says, I only want you to send me the files I haven't seen before. And so that ends up making your pushes incredibly efficient because you're only pushing things that haven't been seen before. Granted, the first guy to deploy that 200 meg app that he's built is going to feel a little bit of pain. But anytime he does revisions to that app, and anytime anyone else made a change or uploads an app that has similar files, they're not going to feel that pain. It's kind of like priming a cache. So, so we get that packaged up app that VMC has sent us. On the cloud side, we then open that app up. We rejoin all of the other SHA-1 based files that are required to put that app together. We've also determined what runtime it uses. So is it a Rails app that needs Ruby 1.8.7? Does it use 1.9.2? And then also trying to shove in what frameworks, et cetera, are required. And that works the same, by the way, across all the other languages we support too. So it could be Java or Node or pick your poison. So we do that and we combine those, and once we've combined that, we create another SHA-1 hash, and that's of the completed package. That is then examined, and we figure out what is needed to actually start your application successfully. So that's where we build an app package. That app package determines, do you rely on MySQL? Do you rely on Redis or Mongo? What are the things necessary to get this app bootstrapped and started so that it can be used? And that ends up becoming an app package. Once we have that app package, and again, we're doing a SHA-1 hash against the app package and any of the necessary things we need, and we store that as well. And let's say you're just doing a single instance, what will then happen if you've requested for the app to start is a request from the cloud controller will be sent out to the DEAs, and that request says, I need somebody that's capable, let's say our runtime's 1.9.2. It'll say, I need a DEA capable of running a 1.9.2 Ruby app. The first DEA to respond across NATs that's capable of running that app will be the one that gets the app package. So it'll receive the app package, it'll bootstrap it up, bring it online. When it does, it will then register that with the routers. The routers will then register that app as being online. The health manager will see that the app has come online if it's a single instance in our case. And in the meantime, your VMC client, where you've said VMC push, is every now and then polling to see what the current state of the app is. Has it achieved a started state? Has it crashed or failed, or what it is? So that's happening asynchronously. So in fact, almost all activities inside of Cloud Foundry happen asynchronously. So once your app comes online, then you go to hit it, you go to whatever the URL you've chosen is, you pass then through the load balancer, through the router, you're pointed over to the DEA instance that happens to be running your app, and you hit the app, and whatever your application's going to do, that's what's returned to you. And so what's interesting is then if you type something like VMC instances, my app instances, say 5, and you decide you want to scale it out to 5 instances, at that point the cloud controller sends out 4 more requests for that same app package that we deployed before. And the next 4 DEAs to respond are the ones that get those next 4 app packages. And believe it or not, it actually works very well, evenly distributing the load across all of the different DEAs. Instead of trying to load balance based on sending the request to the DEAs, we load balance based on how the DEAs are allowed to respond to requests. And the distribution works very, very well in that way. So that's in a nutshell of how it works. What I'm going to do now is take questions. I can kind of answer whatever you'd like. Across NATs, by the way, in case I didn't mention, all of those messages are JSON-based. They're actually all fairly easy to read. The code is on GitHub. It's github.com/cloudfoundry. And the code's actually pretty readable too. It's pretty high quality code. We even have some partners that do Cloud Foundry deployments pulling directly out of the repo to do the deployment every single time. So the code's always in working order. So does anybody have questions?
Yeah, what are some of the other services on the roadmap?
So several other databases are on the roadmap. I can't exactly disclose which ones. We're also looking at external providers as partners, so capabilities such as email indexing. That's email and indexing, not email indexing. As well as a whole bunch of other services. We're also working with other partners that are bringing on other platforms as a service that are derived from Cloud Foundry. An example of that would be Staccato by ActiveState. They actually built a PaaS from the Cloud Foundry code. And there are a couple of others in the works as well that I just can't mention right now. Other questions? Yes, Jim?
How does it compare to Roku with the cost?
So the cost right now is free. While it's in beta, it's entirely free. You're capped at 2 gigs of RAM, but that's really the only cap. So you can spin up quite a few, I don't know what the limit is of the number of service instances, but you can spin up quite a few services instances against the system, along with being able to use quite a bit of CPU, all as long as you're staying under that quota of 2 gigs. That's while it's in beta. When we go to production, there will be some type of charging model. I'm pretty sure we're always going to have some level of a free tier, and then as you move up, you'll also get things like an SLA and a bunch of other things based on the service. And we actually run our own service, so we do not we're not running on Amazon. We're not running on any of the other general providers that you see out there. We actually run our own stuff. So that would be another difference. Another is that our code's open. So that would be another difference. You can actually download and use this and change it and make your own PaaS. That would be another interesting difference. So you could even be free forever, right? You could deploy it on a machine at your home and use it like that.
So I understand that all the Lone Star review attendees will get access, is that correct?
Yes. If anyone wants an account on Cloud Foundry, usually you have to sign up and you have to wait to get in through the queue. If you come to me after, you can sign up, come to me, give me your email, I'll type it in, and you'll instantly be approved. So I have the God power. So if you're interested, glad to do that. We also have some T-shirts if you're interested in a T-shirt. Questions? Yes?
When you add a database like Mongo, does it automatically handle, like if you have a cluster set up, notify, or do you just have to use the API to get, okay, I have new Mongo, and then do the normal Mongo stuff to add that as to the clusters and shards?
So that is planned right now with the service that's open. You can't choose replica sets or shards. You're strictly bound to the single instance that we provide. What I will say is it's in the works to be able to do something like that. How exactly you do that, we're actually interested in hearing feedback, because we've gotten different requests on how people would like to do that. So if you have some specific ideas, would love to hear about them after. We're working on several different projects to deal with different ways of either doing auto sharding, or do we just leave it up to you and tell you, well, you know, you're going to have to go and manually do this yourself. We haven't figured out which way is the best approach, or if there is even a best approach. But right now you're limited to a single instance. What you're running on, however, is far more what I'd call enterprise-grade infrastructure than what a traditional kind of cloudy PaaS would run on. Yes?
Do you have some kind of search engine, like Sphinx or Solar? Or...
So we've been talking to some third parties. What you could do is, because we support Java as another language that you can deploy, you could actually deploy your own Solar instance, and you could talk to that instance from one of your own apps if you chose to go that path. You can also share services between your applications, which is something, I don't know if that came across incredibly clear or not with the front-end, back-end example, but I've done a whole lot of different projects where I've tied a whole bunch of apps to the same Redis backend, and in fact, I've even used Redis as a message bus. So there are a lot of different approaches you can take. We're also looking, though, and you can consume outside services today. We're just looking to make it easier to consume those outside services through partnerships and things. There's nothing built in at present that you could just point to and it's instant Solar or instant Sphinx or whatever. Okay, well, if that's all the questions, thank you very much.